Good morning, children. Today we will do the covering of revision of this topic, Snell's law, right? So there are three ways of representing the refractive index. What is that? Number one is Snell's law. What is Snell's law? In this, we will take the sine of angle of incidence, sine theta of angle of refraction, and when we divide them, we get a constant value which is known as refractive index, right? And this constant value is represented by small n, right? But in this Snell's law, there are two conditions. One, that the angle should be between 0 to 90 degree only. Angle of incidence should be between 0 to 90 degree only. That means neither it should be 0 nor it should be 90 degree, because along the normal, no refraction will take place. All of you know this thing. Along the 0 degree also, no refraction will take place. So the angle should be 0 to 90, between 0 to 90 degree, right? And this refractive index, Snell's law of refractive index, is also the ratio of when light is traveling from medium 2 to medium 1. You have to remember this as it is written in NCERT. This is called refractive index of the second medium with respect to first medium, right? So this is N2 upon N1. But if I ask you to reciprocate it, means if I say you, if the light is traveling from medium 1 to medium 2, how will you represent Snell's law? Soumya,
Ma'am, n by 1 upon n by 2.
it will be sine. Snell's law I'm talking about, beta. Snell's law is sine I upon sine R. And this is N21 when light is traveling from medium 2 to medium 1. But if I reciprocate, I am asking that light is traveling from medium 1 to medium 2. Then what is the refractive index?
And sin r upon sin I.
Yes, it will be reciprocated, beta, because this will be equal to nothing but N2 to N1. Agree? Agree? So it will
Yes,
be
ma'am.
reciprocated. Therefore, it will be represented by sine I, sine R upon sine I. Is it clear? Right? So this is the one way of representing refractive index. Now we need to understand that why we need to find out the refractive index. What is the reason? The reason for finding the refractive index, that we were willing to know that when light travels from one medium to another medium, how it changes its path, how the speed of light is changed, how much, up to which extent it bends towards the normal or bends away from the normal, how much change of the angle take place. So all these questions we will get the answer in form of the refractive index. But the thing is that we have three different ways of representation depending upon the situation. So number one we have done, that is Snell's law. What is number two situation? Now, the second way of representing refractive index is known as absolute refractive index. Why we are saying absolute refractive index? Because in this medium, in this way of representation, we will learn that when light travels from perfect vacuum to the particular medium, glass, water, whatever transparent medium, how much extent of change will take place, how much optically this particular medium is denser or this particular medium is rarer, right? So what is that? Absolute refractive index. And absolute refractive index of a medium is represented by C upon V. What is this C? C is the speed of light in the air or vacuum, and V is the speed of light in the particular medium. Then the refractive index of the medium or absolute refractive index is represented by small nm is equal to C upon V. What is the unit of it? Anyone? Ananya, Chalak. What is the unit of refractive index? What is the unit?
Ma'am, it's a unitless quantity.
It's a unitless quantity. Why? Because it is the ratio of
Ratio of
similar physical
similar
quantities,
quantities.
right? It is the ratio of speed of light upon speed of light. So when it is ratio of two similar physical quantities, they are going to be cancelled each other and the quantity becomes, physical quantity becomes unitless. One more thing we have done in this chapter. What was unitless? Which was unitless? What was that?
Magnification.
Very good. Magnification. Why? Because magnification was also the ratio of two similar quantities. Either it was the ratio of height of image upon height of object, right? And
Distance of
it
image
was also ratio of V upon U.
distance.
Image distance upon object distance.
Object
That is also unitless because similar physical quantities are there. Centimeter upon centimeter or meter upon meter. Right? Clear to everyone? Clear?
Yes, ma'am.
Now, on
Yes,
the
ma'am.
basis of this, when we have experimented for different medium, we got the different values of refractive index for different medium. As you can see, air have 1.003 and diamond have 2.42. So what do you think? Which is the medium is stronger or optically densest? Which is
Diamond.
Ma'am, diamond.
optically denser medium is diamond? Very good.
Diamond.
Ruby is also strong. But if I say rarer medium, which is optically rarer medium?
Air.
Air.
Ma'am, air.
Air. Right? One interesting thing you will learn here by what looking at this table, that what is the refractive index of kerosene oil? What is the refractive
1.44.
index of kerosene oil?
1.44.
1.44. And what is the refractive index of water?
1.33.
1.33.
That means optically kerosene oil is more denser or less denser than water?
Ma'am,
More
more
dense.
denser.
More denser. That means bend towards the normal will be more in kerosene oil and less in water, right?
Water.
So kerosene is more optically denser. But if we talk of mass density, what is mass density? How do we represent? Mass density is equals to, you have done in 9th class, beta.
Gravity into. Ma'am,
No,
area by
mass
volume.
upon volume. Mass upon volume.
Density.
That is, unit was kg per meter cube, right? So when we talk of mass density, whose mass density is more, water or kerosene oil? What do you think?
Ma'am, kerosene.
No.
Ma'am,
Mass
water.
density of water is
Water.
Ma'am, because
high.
oil is
Because
lighter than water.
floats. Yes, any
Yes,
oil
ma'am,
floats
that's
on
why
the water. Any oil floats on the water because their mass density is less than water. इसे आप ऐसे भी याद रख सकते हो, ऑयल में आप देखते हैं लिखा हुआ 900 ग्राम is equal to 1 liter.
Yes, ma'am.
This is why, because oil have less density. Oil have less density. So vegetable oil, they have 9.1 gram per centimeter cube is the density, while the water have, sorry, 0.9 gram per centimeter cube density, while water have 1 gram per centimeter cube density. So water have more density, right? That's why water floats at the surface of water. While if we see optical density, then kerosene oil is more denser than water, right? Clear to you? So it is not necessary that if a medium is optically denser, mass density is also higher, or vice versa. If mass density is higher, it is not necessarily that is optically also denser. Clear to everyone? Right? Clear hai?
Yes, ma'am.
So now we will move for the third topic in the refractive index only. Third way of representation is relative refractive index, right? Children, what is this? This is relative refractive index. Why? Because we are comparing the speed of light from medium 1 to medium 2. What is medium 1 here? Medium 1 is air here, and the second medium is glass.
Glass.
When light is traveling from medium 1 to medium 2, the refractive index will be represented by speed of light in the medium 2 to speed of light in the medium 1. How this indirectly relation has come? Anyone? It's better to write and more convenient for you to write like this. So you will not get confused. Light is traveling from medium 1 to medium 2. Can I write it N1 upon N2?
Yes, ma'am. Yes, ma'am. We can
Yes or
write.
no? Right? To the N1, because N1 is the absolute refractive index of the medium 1, right? So can I write it as C upon V1? Yes or no?
Yes, ma'am. Yes, ma'am.
And to this N2, can I write C upon V2?
Yes, ma'am. Yes, ma'am.
So what will be cancelled here? What is the common?
Ma'am, C.
C is the common. So what is left? We are left with
V1 by
1
V2.
upon V1 upon 1 upon V2.
V1 upon 1 V2.
So when we reciprocate it, we get V2
V2 by
upon
V1.
V1.
upon V1.
So that's way in NCERT, this direct relation have been given. Or you can remember that N was inversely proportional to V. We have learned in the last formula that absolute refractive index is equal to C upon V. So if I remove C from the absolute refractive index, which is a constant value, so can I say that N is inversely proportional to V?
Yes, ma'am.
N is inversely proportional to V. गुण थोड़ा सा ऊपर करिए पेज को. N is inversely proportional to V. Right? Agree?
Yes, ma'am.
That's way we got this relation that N12 can be represented by V2 upon V1 because they are reciprocately related to each other. Similarly, if light travels from medium 2 to medium 1, right? Now the arrow is like this, medium 2 to medium 1. Then if light is traveling like this, we can say that N21 is equal to V1 upon V2 because they are inversely proportional. Agree? So similarly,
Yes,
this
ma'am.
way, step by step, you can write and find out these values that N21 is equal to N2 upon N1. What will be N2? N2 क्या होगा बेटा? What will N2?
C upon
C upon गुण थोड़ा
C.
ऊपर कीजिए बेटा, it is overwriting it.
C upon V1.
Above that. Yes. So N21 is equal to N2 upon N1. Yes?
Yes, ma'am.
N2 क्या है? What is N2?
C upon V2.
Upon V2, right? And what is N1?
C upon V1. C upon
C upon V1, right? C upon V2 upon C upon V1. So C से C cancel हो गया again. What we get?
V1
What we
upon
get?
V2.
V1 by
V1 upon V2.
Clear to everyone?
Yes,
This
ma'am.
was the way of finding the relative refractive index. Note down in your book because the steps are missing here. In NCERT, steps are missing. ठीक है? Noted?